The satellites are coming off the dispenser. They are coming off first the top two from the top hat. We call the bit on top the top hat. And then 4 at a time. So we have a total of 9 separations for the 34 satellites. And you can see here so you can see the dispenser and then the sort of gold spheres on the bottom. That's the frigate, which is actually doing the driving and all of the work. And actually telling the satellites when to go. And the satellite's only job is to let go when it's told.
So why do we have 19 minutes, David, between each of the separations?
So it's important for us that the satellites all have a little bit of different velocity when we let them go. We want them to sort of spread out after we release them instead of releasing them in a bunch. So what we have to do is after we release the satellites, we have to orient the frigate to burn the thruster for a very short period of time, just a little kick. And then reorient back into position again so that we can release the 4 satellites in the correct directions. So it's got to be oriented properly. So that whole maneuver takes a little bit of time. And so 19 minutes is the amount of time to give us both the right amount of delta V, the difference in velocity, plus enough space between the satellites.
And velocity, of course, meaning speed. So we call the process of preparing the launcher and the satellites for today, we call that the launch campaign. And there's a whole set of activities that happen during that time. So let's hear about a few of them now.
The majority of the team arrived here in Baikonur on January 16th. The satellites arrived on January 17th, and for the first week, the satellites were inspected, the batteries fully charged, and the satellites were integrated onto the dispenser. January 25th, the dispenser with the satellites was integrated to the frigate upper stage. On January 27th, the entire stack was encapsulated into the payload fairing and then moved to MiG-40, where it was integrated onto the Soyuz launch vehicle you see behind me. So yes, I'd like to thank our key participants here at the launch campaign. From OneWeb Satellites, who manufactured the satellites, Arianespae, our launch provider, along with Starsem, Ruag team, who's done a great job, and of course all of our Russian partners here at the Baikonur Cosmodrome.
So there we have it, pretty cold there in the in Baikonur at the launch zone. It gets very hot in summer and it gets very, very cold in winter. So the final countdown started about 4 hours ago, Vincent.
Yes, 4 hours ago.
What's happening now?
The State Commission authorized the fueling of the Soyuz with propellant, of course. And this operation was completed 1 hour and 25 minutes before liftoff. 10 minutes before liftoff, the frigate upper stage has sent its readiness to the Soyuz, so the readiness of the upper composite, that is to say all elements inside the fairing. And now we are at 5 minutes to the liftoff. The beginning of the launch vehicle final automatic sequence will be initiated manually with a turn of a key start in start position. So an operation called Kluczna start, yes.
Yes, Kluczna start, which of course means key on start. And Vincent, keep talking to us about what we're seeing now, because this is the launch campaign that we actually discussed earlier. These are some of the events that we heard about.
So the launch vehicle has been prepared in the MiG-40 in Baikonur. So the MiG-40 is the launch vehicle integration building. We can see here the integration of the first and the second stage of the launcher. In the meantime, we have performed the preparation of the upper composite in the MiG-112, and this upper composite has been transferred to the MiG-40 for its rendezvous with the launcher. And we have performed first an integration with the Soyuz third stage, and then with the first and second stage. You can see the final integration in this building facility here.
And it's interesting that the dispenser in there is actually horizontal and is mounted to the frigate on the side. So the mounting and the dispenser itself has to be strong enough to hold the whole thing up horizontally during this integration phase.
So last Monday we performed the rollout in early morning. So the transfer from the MiG-40 to the launch pad number 6 in the Baikonur Cosmodrome. Once arrived, the complete launch vehicle has been vertically tilted. You can see the tilting trolley here. And once positioned on the launch pad, the servicing platform has been installed around the launch vehicle, and after we have initiated the launch pad activities and the final operations.
And that green structure you can see there around the launcher is called the gantry, the clamshell gantry, because that actually opens out in this direction to, well, sort of in both sides. Shortly before launch, that's already open, hasn't it? So just take a look at the launch vehicle. Let's see if we can have a look at it. It's very dark. I'm not sure if you can see it, but there is actually a big grey mast attached to that. We call it the KZM. What's it doing?
Yes, well, it includes, in fact, the umbilical links. These links are specific electrical links which ensure communications between the ground and the launch vehicle upper part. So these connectors are separated 2 minutes and 25 seconds before liftoff and dropped into a basket. So we cannot see this operation because it happens behind the launcher on the screen. Yeah.
We are 2 minutes to launch. Let's just talk about some of the things to watch out for. So that big grey mast will retract, move away, pull away from the launcher just before liftoff. And then there's another mast underneath it which will also pull away. Let's have a quick word about the ignition sequence, Vincent. We switch the engines on 16 seconds before liftoff.
Yes, so this sequence consists in a progressive increasing of the thrust level. So this progressive sequence enables to check that the engines work nominally. So the ignition 16 seconds before the liftoff, then a preliminary thrust level 20% at 11 seconds before liftoff, then intermediate thrust level 85%, 4 seconds before liftoff, yes, and finally the full thrust level at the liftoff time.
Known as Pusk.
Pusk, yes.
So 1 minute, coming up to 1 minute to the launch of our satellites, David. This is your second batch about to lift off.
So this is obviously remarkable. It's fantastic to see the rocket. I'm excited on many levels. I think for OneWeb, this isn't that we've waited a year for 34 satellites. We've waited for a year so that we could build 34 satellites a month.
Okay.
So this is really the start.
And that's very exciting. So 35 seconds to launch. Let's sit back now and watch the launch.
Параметры конструкции ракеты-носителя в норме. Стабилизация изделия устойчивая.
And there she goes. The next 34 OneWeb satellites have begun their journey. They're heading out north over the steppes of Kazakhstan, and Soyuz is pushing hard against the Earth's gravity. Vincent, we're burning the 4 boosters at the moment and the engine on the main core stage, but it's really the boosters that are doing the work right now.
The first stage of the launcher consists in 4 boosters around the central core, so 45 tons each, and each powered by one RD-107 engine, producing, yes, a total thrust of 340 tons at liftoff. So the job is to get the launch vehicle away from the Earth. Yeah.
Because, of course, gravity makes it hard for us. Off. How are you feeling now?
Always a little nervous. It's like a roller coaster. You know everything's going to be okay, but I'm just very excited to see them up and safely where they're supposed to be.
So let's have a look at the tip of the nose of the launcher there, and there you can see the boosters falling away. This is the scheduled moment for separation of our boosters. They burnt all their propellant. We don't need them anymore, so they can fall away. And we're shedding weight. The lighter we are, the faster we go. That's the name of the game. We're burning the
separation confirmed of the booster, yes.
And you have separation confirmed. So Vincent is getting information in his ear from the teams in Moscow. So that's good. We can confirm separation. So we're burning the main core stage now.
Yeah. So this is the flight of the second stage of Soyuz, so the core stage, and during approximately 3 minutes, and after that, so the
next stage.
Yeah.
And we said you're getting information in your ear. Where is that coming from?
So it comes from teams in the CVI. So CVI in French, it's Contrôle Visuel Immédiat. So it is an operational team who is tracking the launch vehicle and receives the telemetry data from the launcher, so they can consequently confirm when the major events have occurred.
And at the Guyana Space Center, the CVI team have their offices on a hill so that they can receive all the telemetry, the information coming from the launcher. But of course, on this occasion, they're in Moscow, in the Mission Control Center there, which is known as TSUP. I believe that's where they are. So we were looking earlier, we could see the top of the launch vehicle. Let's see if we can have a look at it now. We call it the fairing. Maybe we can see the pictures of the simulated pictures. Look at the right-hand side of the launcher, the top of the launcher. The fairing is encapsulating our satellites with their special dispenser, and it's protecting everything inside it from the rigors of the launch, Vincent. What kind of things?
Yes, the fairing has several jobs. So most notably, it's protecting the satellites from the severe condition of the launch and atmosphere. So the acoustic vibration at liftoff, so very loud vibrations, and also friction when the launcher is flying through the dense part of the atmosphere at very high speed.
Very, very high speed. We're traveling at speeds of kilometers per second. We will be reaching 8 or 9 kilometers per second later in the flight. So we're coming up, the next thing that we will be expecting is for the fairing to separate, because we're now getting to over 100 kilometers above our planet, which means that the friction which Vincent was telling us all about is no longer an issue, and we can separate the fairing. You can see it there. We've also separated, this is also the scheduled time to separate the second stage, and hopefully, Vincent, you'll be able to confirm that for us. But David, the captain has switched off the seatbelt signs. We're in space. It took us less than 5 minutes to get there. David, you can see your satellites for the first time. Do you want to tell us what we're looking at here?
Sure. So what you can see there is the 34 satellites on the right and the frigate, which they're attached to, and we still have the third stage pushing it along. But the 32 satellites are all held onto there, and we're going to release them, as you saw earlier, from the top. So first the top 2 from the top hat, and then the rows going down there. There's sort of this trapezoidal shape, this sort of truncated triangle shape, so that they fit neatly on the dispenser, so that we could build the satellite with the maximum possible volume and still fit efficiently a large number of satellites under the fairing for this rocket.
So when you say they're a trapezoidal shape, could you say they look like a pyramid with the top cut off?
Yes, absolutely. Or as I was growing up, it was like a slice of pizza that my brother got to first and took 3 bites out of the end.
Very unlucky. What's the separation order?
So we are going to start with the top 2. And then we're going to work away from the top down to the bottom. So the top 2, and then 4 on the first ring, and then the last 4 on the first ring, and sort of interspersed. So you get 4 coming out in right angles to each other in 4 opposite directions.
And how do they actually separate?
So the separation is done using a very tried and true technique called explosive bolts. And these are actual bolts, like a bolt that you thread onto something, and they are actually installed at our factory. And they have a little pyrotechnic in there, and there's a signal that will be sent from the frigate at the right time to explode the bolt, and suddenly there's nothing holding the satellite in anymore, and there's little springs that push the satellite very gently out.
I always think it's amazing, really, because when you see the images on the screen, it looks like everything's traveling quite slowly, but of course it's all traveling very quickly up there. But what we're effectively doing then is pinging the satellites out into space and giving them that push.
A very, very gentle push. When you see the simulated results, it looks very stately. It's a very calm process.
And David, can you just talk us through the parts of the satellite?
Sure. If we could pull up the picture of a OneWeb satellite. So this is a picture of one of the OneWeb satellites after it's been deployed. So when it's in the dispenser, the antennas are folded up, and the solar panels, the wings there, are folded up as well. When it comes out, everything is going to deploy. And you can see here all of the important parts that make the satellite work. So you've got the solar panels on the outside, which generate the power. You've got on the bottom this sort of deck of cards fanned out look. Those are the user antennas. Those talk to the user terminals on the ground. And then the 2 sort of round TV dishes on the top there that look sort of to me like butterfly antenna, I can't get that image out of my mind, are what attached to the gateway. So, and there's electronics in there to boost the signals through from one antenna to the other. So it's a very, I don't want to say a simple design, obviously a lot went into it, but there's a certain economy of design that went into these satellites to get them so small.
Vincent, have we had any information yet?
Yes, we have some confirmation. So we confirm that the Soyuz works nominally. So we are now in the 3rd stage flight, and everything is nominal.
So when we say everything is nominal, of course, that means that everything's going according to plan.
Yes.
Which is great. So we're coming up on the next stage, or the next scheduled stage, which is the 3rd stage separation. And I just want to, you may have noticed when you saw the launch vehicle on the ground, there's actually a sort of a lattice section, an open section between the 2nd and 3rd stages. We call that a hot stage technique, because when it separated the 2nd stage, it actually switched the 3rd stage on first before it separated the 2nd stage. But this is now the scheduled moment to separate the 3rd stage. So we are shedding weight again at the 3rd stage, shutting its engine down. That's what it looks like up there. And we're really starting the next phase of the journey now, because the frigate upper stage, which is that gold structure that you can see, is going to take the wheel. And it's getting ready to switch its engine on, isn't it? We call it the pre-burn.
Yes, and we confirm the separation of the upper composite right now. So there is now a pre-burn of the frigate, the first step, yes, during 55 seconds. It's given a quick burst of acceleration to push the fluids back in the tanks. So like when you accelerate in the car, in fact, you get pinned back against the seat. So after that, we have the ignition of the main engine, and during 4 minutes, and this first ignition, yes, is performed to inject the nose module into an intermediate transfer orbit, which is an elliptical orbit.
So let's just talk everybody through that for a second. So we have at the moment, we're going to be going on an elliptical orbit, which is oh, you'll have to excuse my bionic hand, by the way.
Why don't I try this one, Katie?
Yes,
you start off here, and you launch up, and then you need a kick to get you into elliptical orbit that will go around like this, take us halfway around the world, and then we get to the top here, we have another burn that will make this elliptical orbit into a circular orbit.
Yeah.
So that's the reason why we are switching our engine on
Exactly,
right now,
yes.
to get us into that orbit. So 11 minutes and 14 seconds into our flight. David, we drop off your satellites at 450 kilometers above the Earth, but of course that's not their actual final destination. They're going to have to travel further. We will be seeing that later, and we will be talking about that later. They're going to be traveling on their own for about 750 to 700, no.
They'll be traveling to 1,200.
1,200. So they'll have to travel 750.
Yes, further than last time.
Yes. So let's see how our satellites are going to get there and what they're going to do when they actually get to their final destination in space.
The following animation shows components of the OneWeb system design. Unlike geostationary satellites that operate at an altitude of 36,000 kilometers, the OneWeb system operates at 1,200 kilometers, resulting in significantly lower latency and better system performance. Our system will provide full global coverage, which is shown here. The gateways are shown here in red. The teardrops moving around illustrate the OneWeb satellites in orbit, which will communicate with the gateway infrastructure for connection to the internet. End users will connect to the satellites via OneWeb user terminals. As satellites pass over users, the terminals, represented here by a white dot, will hand off connections between beams and then to the next approaching satellite. The resulting connection and connectivity will provide high-speed access as shown in the download simulation here.
Any news, Vincent, on our...
Last news is confirmation of the pre-burn for the frigate, yes.
So that's good news. So, David, it does seem that there's an awful lot more to your system than simply satellites.
That's right, and we've been doing a lot more in this last year, besides building up these satellites and building up the satellite factory. In fact, if you show the image on the screen, we have... Do we get the image? Maybe, maybe not. I was going to show an image of one of our ground stations. Ah, there it is. So we have an image of our ground stations here. This is one in Florida. We have over 40 around the world, and we are in the process of building these out. So in addition to all of the high tech and space and whatnot, we have some concrete and water lines that we need to deal with. And these are actually all pointing straight up because they're not being used. That's known as the bird bath configuration in the satellite dish world. But when they're actually used, you will see them nodding back and forth as they track the satellites flying overhead.
So we're coming to the next phase of our flight now, which is the switch off of the frigate engine, and we're going to be entering what we call a ballistic phase,
yes, so
which is going to be, and this is the scheduled moment for frigate to switch its engine off. That's what it looks like. The frigate is the gold structure, and the dispenser or adapter, as we sometimes call it, is what we were looking at there. So we've entered the next phase, Vincent, which is called the ballistic phase, which, am I right in saying it means no power?
Yes, this is a phase without propulsion. So we're traveling high enough and fast enough to cruise without the engine. So during this phase, we optimize the orientation of the launch vehicle in order to ensure the best condition for the frigate, but as well for the satellites. And the duration of this ballistic phase is quite long. It's 51 minutes. And we confirm that the first ignition was completely nominal, yes.
That's great news. Thank you very much indeed. Well, I can imagine that the folks in London are very happy. They watched that launch. It was a very beautiful launch. So let's go back over to Sue Nelson now in London and get some reactions. Over to you, Sue.
Thank you. Everyone here in London is delighted with the progress so far. And when you think of OneWeb, you automatically think of connectivity. And I'm joined by Ben Griffin, who is the lead on the commercial aviation team. So how do airlines benefit from OneWeb satellites?
Well, there's lots of ways that airlines benefit if we think about the passengers themselves and the proliferation of connectivity with devices. Airlines are kind of struggling to meet the demand of more and more passengers who want to be connected throughout their journey. So providing greater capacity, greater bandwidth, greater coverage is certainly going to help meet the needs of airlines and their passengers. And the other perspective as well, the modern airliners are producing more and more data, which if they can get that data off the aircraft in a more timely manner tells us more about the aircraft, how they're performing and the routes they're flowing. So there's no end really to the benefit we can get from getting the data off the aircraft and providing more capacity in order to do that.
And it's not just the airline industry that's going to benefit either.
No, that's right. So it's not just the airline industry, it's the aviation community as a whole, so business jet, military, and other applications, but also the maritime sector is phenomenally big, has a big need to be connected. Enterprise applications, which was very well suited to OneWeb, providing connectivity in places where there just isn't connectivity today, and providing and opening up new kinds of applications and services that benefit from the low latency that OneWeb can provide. As well as that, other government types of applications as well, and not just industry, providing connectivity to schools and healthcare and other things like this.
And scientists, because you're going to, provide coverage to the Arctic.
Coverage to the Arctic, exactly. So places where there isn't connectivity now, all of a sudden opens up a whole new capability through the connectivity that we'll provide.
And so how do you work with organisations and sort of letting them know that this is what you can do, this is how we can expand what you're doing?
Well, things like this, the launch obviously helps, and that's a good platform to do those things. Working with leading industry partners to help champion what we're doing and get the message across. And of course, attending industry events where we can carry our message directly to the markets that we want to serve. Mobile World Congress is coming up in Barcelona later on this month. Aircraft Interiors in late March, early April, and the Satellite 2020 in DC in March as well. So all these key things where we can get our messages across to industry and making the use of events like this to get our message across, yeah.
Now, it's not, telecom satellites, most of them, we think of them in geostationary orbit, but OneWeb satellites are going to be in low Earth orbit. What are the advantages of being in low Earth orbit?
If we start with the pure physics of it, the low Earth orbiting satellites, as the name suggests, are much closer to Earth. So we have a lot less distance to travel, which means the latency is less, which means the messages can and the data can flow much quicker between the satellites and their intended destination. That opens up a whole new load of applications, cloud applications, gaming, other time-sensitive things. I mentioned healthcare before, for example. There's a lot more coverage we can provide across the globe, so we can do the entire globe now without any holes, which simply isn't possible with geostationary satellites. And actually, we benefit from the ability of replenishing the satellite, the spacecraft assets more frequently as well. So there's all sorts of different things where LEO low Earth orbit is highly advantageous compared to geostationary.
And you're making some differences on the ground too, not just in space.
No, that's right. Yeah. So because we're new and we have the luxury of a whiteboard, effectively a blank whiteboard, we can build the new systems, the new billing systems, operational systems, to make sure that we can cater for and adjust to the market as it develops. So we're not restricted by old things like that. Equally, embrace technology on the ground much more readily and make sure we can pivot and adapt to the way the terrestrial world is going, which is moving at such a pace. It's a good thing to be able to keep up.
Well, thank you very much indeed, Ben Griffin. Back to you, Katie, in Paris.
Thanks very much indeed, Sue. We're going to take a break now in our programme for about 40 minutes or so, and we'll come back to you at 10:41 UK time, 10:41 London, that's 11:41 here in Paris, and in Baikonur that's 3:41 in the morning. We'll see you then. batch of 34 satellites in the OneWeb constellation on their way to their final destinations in space. And joining me here in the studio, we have David Nemeth, who is from OneWeb. David, thanks for coming back for the next part. And we have Vincent Baudel, who is from Arianespae. Arianespace responsible for launching OneWeb's satellites. So, right now, the satellites are riding bareback on board what's left of the upper stage, hurtling through space at phenomenal speeds.
But not with the wind in their hair.
Not with the wind in their hair. And let's just check in and see what's been happening. Vincent, talk us through. This was the launch. We lifted off 1 hour, 1 minute and 20 seconds ago from the pad at the Baikonur Cosmodrome. And I have to say it was a really beautiful launch.
Yeah, outstanding one, yeah. The mission started with, yes.
With the liftoff, yes,
yeah,
and we're going to see some images in a minute, but this launch itself, this was the replay of the launch.
Okay.
And we actually saw the 4 boosters there. You can see those burning. And what happened next, Vincent?
Yeah, so after the boosted phase, the second stage of the launch vehicle took the rein during 3 minutes. So few seconds before separation of the core stage, the third stage was ignited, yes, and the central core was then separated. And 2 seconds later, the fairing was jettisoned. So the velocity achieved at that time is 3.6 kilometers per second. After the flight of the third stage and its separation from the nose module, the velocity achieved at that time is 7.2 kilometers per second. So the frigate upper stage took the wheel with a first ignition of its main engine during more than 4 minutes to reach the intermediate transfer orbit, followed by a ballistic phase without propulsion lasting 51 minutes, and a second ignition with a shorter duration for circularization and injection into the spacecraft separation orbit.
So that's what's been happening up until now, and we've still got a few more drop-offs on our school bus to go. But before we do that, let's go back to London and see how everyone's getting on over there. Over to you, Sue.
Hello and welcome back. Well, among the guests here at the OneWeb watch party are some of the students who took part in a recent space hack at Imperial College London. Now, around 100 students took part. It was sponsored by OneWeb, and they were all sort of divided into teams. And what they had to do was to provide solutions to some space industry problems. Now, one of the organizer of that was Jawed Adel. He's a 4th-year engineering student. He's also the president of the Aeronautical Society at Imperial College London, and he's here with me now. Those problems that the team had to solve, give me an idea of some of the problems.
Of course. Firstly, I'd just like to thank you for having us here, and thanks to OneWeb for inviting all of us at this wonderful launch event. Right, so to answer your question, right, essentially the space hack was about finding creative solutions to these pain points within the space industry, and more specifically with this partnership with OneWeb, the focus was on these low Earth orbit satellite constellations. There were 5 main challenge streams, namely satellite operations, satellite engineering, satellite-enabled world, responsible space, and commercial. To give you a brief description of just a few of them, for example, one of them sought to find innovative solutions to the problem of space debris that we have today, or more seriously, we might have tomorrow. Another was how to monitor each one of these individual satellites in a 600+ feet of constellation. And another, a favorite one of mine was actually how the satellite connectivity all around the world would help unlock new business potential in developing nations. So as you can see, these were all varied problem statements which just asked for a creative solution.
So the emphasis then was on the creativity. It involved engineers, science, business people from the sound of it.
So it was quite interesting because the reach that we had, the event had, it was not only aeronautics students from our department, but there were people from physics, there were people from computing, and even people doing an MBA in the business school. And also there were not only people from Imperial, but outside, there were Cambridge, Oxford, King's, and UCL as well. So it had a wide range of people participating.
And which team won in the end?
So it's a team actually within the aeronautics department. There were a team of second-year students. Their solution was to the problem of space debris. What they essentially devised was this module that they decided to call Spider-Man, which stands for Space Instrument for Debris Removal and Maneuvering.
That's brilliant. That's absolutely brilliant. Now, before we go, because we're about to hand back to Paris, what do you think about OneWeb, very quickly, the fact that they've brought you here? Do you think it's encouraged students to be a space industry?
Absolutely. I must say it's encouraged myself to want to work in the space industry, right?
Brilliant. Well, that's it. From the students back to Paris.
Oh, that's great to hear. And the more students we get coming into the space industry, the better. So that's good work from you guys there. And thanks very much indeed for telling us all about it. Coming up to the next big event now. This is the scheduled moment for us to switch the engine on of the frigate upper stage for its second burn. Burns for, 24 seconds. It's not a very long time. And we have been, I just want to ask you about, Vincent, during the coasting phase that we were going through earlier, we've now switched the engine on, so obviously we're no longer coasting. We were doing what we call the barbecue mode, so that's literally turning as if on a spit. Why?
Yes, the barbecue phase. So it is in fact a spin-up mode. It corresponds to a rotation of the nose module around its longitudinal axis. So it is a maneuver which enables to optimize the thermal condition and the sun illumination of the frigate, but of course of the satellites, yes.
Because I guess really it's fair to say that when you're facing the sun, it's very, very hot, and when you're away from the sun, when you're in space, it's incredibly cold. So OneWeb satellites are mass-produced spacecraft, rather like cars on a production line, and it's great to be part of something so new.
We take it for granted that we have internet, but not everybody has access to that right now. So what we're doing is putting that network of satellites strategically positioned so that we can reach those areas that currently don't have access to the internet.
I really like the idea of being a part of a company that's trying to bring satellite coverage worldwide, and the entire process to try to be the company that's the first to mass-produce satellites successfully.
It's pretty amazing because we kind of went from nothing to just beautiful white floors, not being able to build anything, to actually having satellites, and now the satellites are fully tested. We have satellites up there that are already performing really well, so now we're just going to keep building our constellation.
OneWeb has staffed with the most experienced technicians.
Like, we put together a team of over 100 operators very quickly, and leading them and getting them to build like quality products.
We're kind of all hand-picked.
We have a great experienced 5-star team.
My name is Doug Hudson. I'm a launch operations technician. I retired from the Air Force in 2007.
I'm Gwendolyn Sisto. I'm the operations and planning manager at OneWeb Satellites. It was like they had written the job description for me. I studied aerospace engineering, aeronautics, and astronautics.
My name is Florence Trin. I'm the integration and test lead for OneWeb. My dad was my inspiration. He is the reason why I am interested in engineering and math and the space program and space.
OneWeb Satellites has 5 apprentices, and I am just one of the 5. So we're working specifically on the manufacturing of the satellites.
It's been a long time planning, preparing, doing pre-tests, dry runs, and making sure that this process is efficient.
We kind of have a saying, make it happen, Captain. And we've been working 10, 12, 14-hour days, and to get the second launch out is a big accomplishment. I like getting in on the ground floor. It's exciting. There's a little bit of competition there with some of the other companies in the area.
Well, it's been pretty awesome. I mean, look, I'm here at Kennedy Space Center. I have the Antonov behind me. I mean, where else would you get to do this?
It's such an international company. They're very accepting and very open to everyone, and I think that's really beneficial.
It's exciting times and it's cutting edge.
When I thought about aerospace, I never thought about this. This is something that's revolutionary and something that's really exciting.
We're just like scratching the surface of what's possible. So now we've built this whole machine that makes the machine that can be used for all these other applications. We're basically bringing the cost down for space and making it more accessible for the rest of the world to like touch it.
Some very exciting people there with some very big brains. Now the frigate upper stage is getting ready to release the first 2 satellites. That's going to happen in just under 40 seconds now. We need to position them very precisely, don't we, Vincent, so that they can push the satellites into space on a very precise orbit.
Yeah, so we need to put the satellite in the right attitude so they can separate. So to do that, frigate performs a very carefully planned set of maneuvers, by means of small thruster, which constitute the attitude control system. And we call this set of maneuver the orientation phase, yes.
And there we can see what it looks like up there, the separation of our satellites, our first 2 satellites from the top hat, David.
That's right, dropped off at the first bus stop at the corner of Spruce and Elm.
You were telling us about, well, actually, over just south of Madagascar, actually,
yes,
rather than on the corner of Spruce and Elm. David, you were telling us earlier about the separation bolts that allow those satellites to be pinged into space or pushed gently into space. I gather that you visited the factory.
Yes, so I went to the OneWeb factory. I had a fantastic time there. Everyone was very tolerant of me, going around and poking my nose and everything. And one of the things that I got to see was the last stages of the process. So OneWeb Satellites finishes the satellite and they give it to us, and it's our job and our partner's job, RUAG and Arianespae, to install these bolts. And so I actually met Florence, who you saw in the video earlier, and I saw the process by which they put the bolts in. And so I just wanted to shout out to Florence. They just fired, should have just fired. Hopefully all went well. We'll find out about that soon.
So what was the process like?
So it's this great process where the satellite comes down onto a sort of a fixture thing, and they're all busily installing stuff and putting things in there. But there's one part that really kind of stuck out to me is we have this coating over, not this coating, it's a blanket, MLI blanket. It's like a Mylar blanket like runners use. And it's very precision cut to fold exactly over with everything in the right place. When we get the satellite, it's not all finished and buttoned up because we need access under the blanket in a couple of spots. So after they've installed everything, the last thing that they have to do is they have to go through and finishing buttoning it up. And they really have like these little button things. And they're going through and they're buttoning up the MLI blanket, and it's like watching a kindergarten teacher buttoning up the kid's coat so that he'll stay nice and warm when he goes outside.
Before he gets on the bus.
Before he gets on the bus.
And
I guess that would be his father then, rather than the teacher.
Yeah, maybe, yes. And it always amazes me in space, Vincent, some of the things that you were talking about. Actually, things seem very complicated, but at the end of the day, it's down to engineering and bolts and nuts. And let's just talk a little bit, though, about how we're finding out information. You're hearing stuff in your ear, but how is the rocket talking to us, and how do we know what's happening up there in space?
Yes, so we have a team in Moscow. Yes, in Moscow, in the Frigate Flight Monitoring Center. So they got the information from the launcher, the signal from the launcher. When it's possible, that is to say when we have visibility. They got the data from the launcher and they assess this data to see where we are and if everything works nominally.
So that's what is happening right now. The telemetry, as you say, you have big dishes in the various different telemetry stations all dotted along the flight path. picking up the signal from our launch vehicle as it flies over and sending that information back to us. At the heart of the OneWeb program and the OneWeb ethos is a program to connect schools. Connecting schools has always been important to OneWeb, but let's find out, what does that actually mean?
The theme for this next launch is space for everyone, because one of the main purposes of OneWeb is to connect the unconnected. So that connecting school is a core mission of the company, and it's really where our business and our purpose, our vision can come together. We want to connect every school in the world because we want to connect every person in the world, and it's important to us that we connect not only schools in populated areas, but in the most remote and unpopulated areas. You may remember our first launch had 6 satellites, and we went to 6 very remote corners of the world and got 6 schools to name the satellite. We want to help make sure that the skills are there for the next generation to use connectivity, to get an education, and then to do jobs anywhere in the world. When people hear that it's a satellite constellation, they assume they need to be engineers or somehow in a STEM field themselves. But I always point out that I'm a lawyer and I trained as an actress. And it's important to the company that they have people with a wide range of skills. And we encourage everyone to get the skills and apply for jobs at our company. I think everybody who works at OneWeb is driven by this same mission, this connectivity, the idea that we are about to revolutionize the world's access to information in the way that the internet did 20 years ago or smartphones did 10 years ago. This is going to give everybody that same kind of access, and the people who've come to join OneWeb are all excited about this potential of being in the first wave of the new way to communicate.
And this time last year, Arianespae delivered the first 6 satellites for OneWeb. That was in February last year. And those 6 schools all played an important part, didn't they, in that launch?
Yes, so the 6 schools that Ruth mentioned actually named the first 6 satellites for us. Now, we have too many satellites to name at this point, so those are special that they got a name. And I just sort of wanted to let everyone know and let the children who named them know that those satellites have been very hard at work for us this past year.
What have they been doing for you?
So they've been, obviously, the first thing that we had to do with those 6 satellites was validate the performance of the satellites themselves and of the design itself, right? And they did spectacularly well. They met all of our expectations. And once we got through the phase of making sure that everything was okay on the satellites, we really needed to put them to work testing the rest of this complex system, right? So you have ground stations which need to track them, you need to send communications links over them, and so the satellites are an incredibly valuable part of our test program, and will continue to be those 6 satellites. Now we'll have an additional 34 satellites to add to that, and more will go on. So, you know, in addition to testing the communications and testing the payload and everything works, we've flown them up to an altitude, we've moved them down again, and so we've really checked them out to make sure everything is okay, and they've given us the confidence to move forward with this mass production.
So let's go back to how we're getting the information from our launcher. We were talking about telemetry. Incidentally, telemetry is an interesting word because it means it comes from the Greek tele, of course, remote, like television, and the metry section comes from the measuring. So we're measuring effectively from a distance. Let's talk a little bit about those tracking stations, and I think we may be able to show a picture of those.
Yes, so in order to know the launch vehicle position, how it works, yes, we need to get information and signals, so this is the telemetry. And telemetry is got by means of a ground tracking station and a specific dish. We have tracking station along the flight path, of course, and as of today's mission is very long. We have not a full coverage from the ground station. So that's why we need to be under ground station visibility in order to receive information from the launcher and then confirm the completion of the key events like separation. So tonight we use ground station Russian network. So we can see the picture. We can mention, of course, Baikonur, Vorkuta, Plesetsk, Krasnoye Selo, and so on. So this is the network, used tonight to track the launcher, yes.
And of course, Plesetsk is also a launch zone in its own right, and so yes, of course, it has the telemetry station there as well. And let's go back to, because you were telling us about the way the satellites are released, and they're on the special dispenser, which I have to tell you that the last time David and I did a show together, which was a year ago, we thought it looked a little bit like a corn on the cob. But
I never heard the end of that back at the office.
Yes, he had some corn on the cob on his desk when he came home. But it is actually very seriously a very specially designed dispenser, isn't it, to host these satellites?
Yeah, so the objective was to accommodate 34 spacecraft, or 36 for the Vostochny launch, on top of the launcher. So a totally new, specific carrying structure was needed to be developed and manufactured, especially for the OneWeb mission. So a dedicated dispenser has consequently been designed to perfectly integrate the OneWeb spacecraft, so electrically and mechanically.
I'm going to help you out there. So we're going to go
and ensure the release.
We're going to go back to our children now and look at their ambitions for the future.
Who am I? I am one child, waiting to be connected to the internet, to the world, to you. One wish, waiting to be fulfilled. One dream, waiting to come true. Who am I? I am one story, waiting to be told. One life, waiting to be shared. I'm one inventor, or teacher, or leader, or creator, waiting for the technology to take us all one step higher, higher, higher. I'm one transformer, waiting for change. I'm one of the most remote parts of the planet, waiting to welcome you. One place you've never been. One face you've never seen. I'm one pair of hands, waiting to build the future. One pair of eyes, gazing up at the sky. One school amongst millions. One child, waiting for one day when all children will be connected as one.
And that day is not very far away. Right, let's get back to what's happening now. We're 1 hour, 24 minutes and 6 seconds into the launch, David. Do you want to give us a recap on what's happened so far?
So far, we have done our first release of 2 satellites. We have swung over Antarctica, released a satellite south of Africa. We're coming up the east coast of Africa, ready to drop off the next 2 over Saudi Arabia. Of course, the satellites we released are still traveling with us, and they're actually a little bit ahead of us now. So we have a little string of satellites ahead of where the dispenser is.
Oh, why are they ahead of you? They're traveling a little bit faster than you.
So when we do the burns that we're doing in between actually slow us down a little bit. And that's the way we space them out. So you end up with a little marching of the little satellites ahead of the dispenser as it goes. And when it's all released, the dispenser will be back here and all of the satellites will be up there.
The opposite of the Pied Piper.
Exactly. Ducks walking backwards.
Ducks walking backwards. And Vincent, what about the frigate upper stage? What's it doing during this time?
Yeah, so we have a sequence identical between each separation. So the duration of this sequence is 19 minutes and consists in a series of maneuver. So first there is a tilting of the nose module to the required orientation for the frigate attitude control system boost. This boost with very small delta V during few seconds to ensure enough distance between the spacecraft and avoid any collision. After a new tilting of the nose module to the required orientation for the spacecraft separation, then the separation ordered by frigate and a smooth separation of the satellite themselves.
And of course, we have to remind ourselves, we were talking about there are satellites, but satellites need to be flown and operated, and it's the teams in the control center, at the OneWeb Control Center in London and also Virginia, or just London?
London and Virginia, just like the GNOC was talking about, they have two shifts in London and Virginia. We have two operation centers for the satellites, one in London and one in Virginia as well.
So they will be concentrating, I'm guessing, very hard at this point.
They are concentrating extremely hard. They've been very busy. So the last time they had to pick up 6 satellites. Now they're going to have to pick up 34, so their workload has gone up by 6 times. And then every month they're going to have to pick up more. So they've been doing a lot of preparation and a lot of automation to make all of this happen. Although I must point out that they still have enough time to answer the questions that I've been asking them in preparation for this show. So
well, that's
thank
good.
you, Cameron.
That's good to hear. But I guess they also do a lot of rehearsals, is that correct?
They do, yes, they do a lot of rehearsals. They have accurate simulators of the spacecraft for the rehearsals. And of course, they've been practicing a great deal on the satellites that we've got. So those first 6 satellites have been a great test bench for everything and all of the systems that we've got to run and fly the satellites.
So it's been a good year and very successful, hasn't it, so far? We're getting closer now to the next frigate upper stage, switching its engine on. Again, back into that pre-burn we were talking about, pushing the fluids back in the tanks. And here's the images. We can see the computer-generated images up there in space. How do we get these images, Vincent?
So this is a simulation with representative models of the launcher, the dispenser, the satellites, of course, and considering the trajectory data prediction coming from mission analysis performed in the frame of the preparation of the mission. And each step of the flight are then perfectly simulated. So we have seen the boosted phase, the stage separation as well, the orientation sequence, and now we will follow the spacecraft separations.
And each time we switch our engine on, we actually switch it on for a shorter time.
Yes,
Why is
that's
that?
right. So we want to have, every time we switch the engine on, we wanted to give it the same change in speed, but the engine only has one thrust. It's like a car that you can only press the accelerator down all the way. And because it's getting lighter and lighter, because there's less satellites, you need to press the accelerator down for less time to get the same boost of speed.
So we're on our way to our next bus stop. It has to be said that our bus doesn't actually stop. It does keep on going, and it separates the satellites and pings them out into space as it's flying, hurtling through space at speeds between 7 and 8 kilometers per second, ladies and gentlemen, boys and girls, per second, not per hour. So that is unbelievably fast. I haven't calculated what that is in terms of hours. But the next thing is the separation of our next 2 satellites. 4 satellites.
4 satellites
thank you.
now.
And of course, we will hope to get telemetry confirmation when we go back into the range of the tracking station.
Yes, sure.
So 1 minute coming up to, we're due to separate our next 4 satellites in 1 minute and 30 seconds, 1 hour 30. So we're coming up to that, and we're heading out over Saudi Arabia. What's our flight path? Just remind us where we are now.
So we're heading north. We will be over Saudi Arabia when we release these 4 satellites, and continue to head up over the North Pole. And because we are going north and we're going back over Russia, we're going back in telemetry range after the separation.
And we're keeping, our flight path is effectively taking us up over the
North Pole to South Pole.
to South Pole.
So we'll get telemetry confirmation when we're up here. And then as we come down here, we will have another 4 separations outside of telemetry range. And then we won't get confirmation again until we've come around again. So this is our first confirmation of, our first chance to get confirmation of the separation.
So we've done, how much of a lap? Have we done a full lap of the Earth yet?
Almost, almost. We don't come back to the same place. We come back a little west each time.
Is that because the Earth's moving?
The Earth
or
has
is that...
turned a little bit, a little bit. So in the hour that we were out there taking a break and having a coffee and maybe a cigarette, the Earth has turned enough. So we're now coming up west of Baikonur in minutes.
And this is what it looks like up there, the 4 satellites moving away. This is the scheduled moment, moving away.
And the frigate had to position us so that those were all going in the right directions. We couldn't just release them anywhere. We had to get in just the right position and orientation. And
the frigate, of course, if we can just have another look at the images there of the 3D computer-generated images. The frigate is the gold structure at the bottom, and the dispenser, our cob, with its corns, is the structure on the top of it. So, right, it would appear that we've now had our next 4 satellites separated, but we haven't got confirmation of that yet. But what happens to the satellites? What do they do, David, once they've been separated?
So before we ship the satellites, we charge up the batteries, and when we plug them in, it essentially shuts down the satellite so that the battery is conserved and we have time to set up and put it on the rocket and spend that launch campaign days. Once you've fired the bolts and the springs push it off, the electrical connection to the dispenser is separated, and that's a signal for the satellite to wake up. So the first thing it does is the computer boots up. Everything today starts with the computer booting up. My television has to boot up when I turn it on. So just like that, our satellites boot up, come up, and the first thing that they will do is they will deploy the solar panels. They have a special circuit, a very clever little circuit, to melt a wire to deploy the solar panels. And then they will turn and face the sun. So like a plant, you want to get as much energy you can, and instead of leaves, you have solar panels. So you rotate towards the sun and get as much power as you can, and you just sit there, and they wait.
Sunbathing.
Sunbathing.
Now, Arianespae is very experienced at launching constellations of satellites. Let's take a little look at that experience.
I would like to take the opportunity of this OneWeb first launch of the year to highlight the skills of Arianespace engineering and operations team in support of our customers for their constellation development and deployment, whatever the launch vehicle. The OneWeb mission is a concentrate of what Arianespace can bring. In the early phase of the project, ability to understand the core business of the customer, to come with the appropriate concept. Then, while preparing the mission, co-construction with the customer of launch solutions and mission design addressing key mission requirements, such as spacecraft injection altitude, number of spacecraft per launch, or separation sequence.
A dedicated organization has been set up in Arianespace to meet the many challenges of the program and to be able to ensure 1 launch per month during the deployment phase. Regarding launch vehicle, Soyuz was the adequate solution to answer OneWeb requirements to deploy about 650 satellites within a 2-year period timeframe. Soyuz launch vehicle fitting to Constellation's need has been already demonstrated with more than 15 launches performed to low Earth orbit missions for other Constellations programs. The frigate upper stage versatility associated with the dedicated dispenser allowed to perfectly answer to the OneWeb mission requirements. Arianespace and Starsem offer was based on the capability to operate the Soyuz launch vehicle from 3 launch pads, one in French Guiana, one in Kazakhstan, and one in Russia. This unique opportunity provides higher flexibility and reliability for the benefit of OneWeb. Launching from different launch sites will secure the deployment schedule, which is key to OneWeb, and this without preventing to serve other customers.
For OneWeb, we developed as well a smart dispenser to operate, carry, and separate the various spacecraft. And we provided engineering support to spacecraft manufacturers to optimize the spacecraft dispenser design. To make the customer experience in operation as smooth as possible in preparation of the launch, we finally reduced the operation duration in the launch preparation facility.
Pre-integration of satellite on the dispenser at the factory to shorten the activity at the launch sites, allowing the high launch rate of 1 per month requested by OneWeb. OneWeb dispenser is a flexible and modular product. This made very easy its adaptation to the specific configuration of VS-21 with 6 spacecraft and 4 mass simulators. In the same way, we are currently expanding its capacity to 36 satellites for the next flights. Finally, I would like to highlight the very good collaboration between OneWeb, Arianespace and Arianespace, which allowed to develop an innovative product answering challenging specifications.
As you know, multiple customers have already entrusted Arianespace in deploying their constellation on the various launchers operated by Arianespace, with structures provided by CASA, RUAG or Ariane Group. 2020 will be also the opportunity for Arianespace to demonstrate its rideshare capacity with the first SSMS mission that will soon be launched on Vega. To conclude, I would like to warmly thank the OneWeb team for their trust, thank my team for its professionalism, thank RUAG and our Russian partners team for their continued support. We look forward to continue the deployment of OneWeb constellation on Soyuz and on the Ariane 6 maiden flight.
So we've been talking a lot about constellations, obviously because OneWeb is a constellation. But for anybody who's unfamiliar with the term, what it actually means is you've got basically more than one satellite. So you can have 2 satellites in a constellation, you can have 10, you can have 20. OneWeb's going to have over 600, 648, I think, at some stage you'll have.
That, yes.
But it's, I have to tell you, that is an awful lot of satellites. So that's a big constellation of satellites. I guess it takes the name from the constellations. So we've seen there how Arianespace is really well adapted to launching constellations, but why? How?
So for more than 20 years, Arianespace, yes, has developed a real know-how and experience for constellation deployment. So for such a specific mission or objective, is first to co-design with the customer the launch solutions and mission by addressing key mission requirements, that is to say spacecraft injection altitude, optimization of the number of the satellites, and the separation sequence. The interest and advantages of our offer for the OneWeb constellation is also the possibility to propose and use 3 different launch pads. Such flexibility enables to ensure a very high launch rate. So the pilot launch has been performed from Kourou in French Guiana last year in February. And tonight we perform the first launch for the OneWeb constellation from the Baikonur Cosmodrome. So, and then there will be 19 other Soyuz launch from Kourou, Baikonur and Vostochny. Okay, so finally, I would say that the flexibility of the Arianespace offer is ensured by its fleet of launch vehicle, Ariane, Soyuz, Vega, and thanks to their complementarities, this launcher covers all the constellation mission requirements. So a heavy launcher as Ariane 5 can propose launch solution for a very high number of satellites, and lighter launcher like Vega can propose solution for smaller constellation, or for completion of an orbital plan, or for spacecraft replacement.
And of course, it has to be said that the new Ariane 6 launch vehicle will be, the first launch will be your OneWeb satellites, another batch of satellites, obviously. Thanks very much indeed for talking us through that, Vincent. Let's go back to London now and see what's happening over there. Over to you, Sue.
Thank you. Now, as you can hear in London, there's still quite a lively atmosphere here this evening. And this time I'm joined by Sara Mugneni, who's a payload engineer for advanced projects for OneWeb. Now, Sara, could you just remind us what the role of the antenna is, as you are an antenna specialist?
Well, yeah, the antenna is part of the payload. The payload does the work, say, is what pays the bill, is the value of the satellite, is what get the information from one part of the globe to the other part of the globe, is the electronic on board. And then you have the antenna, which is at the end of the payload, is what transforms basically the digital added value of information that you have on board of the satellite in electromagnetic waves that will be then transmitted to Earth to where they have to go. So the payload does the routing, and then the antenna gets the job done and deliver to where it has to go.
Now, the payload on the OneWeb satellite is quite unusual. In fact, I'm not sure I've seen one like it before, because you expect the antenna to be, you know, like a normal, yes, like a dish, and this one is sort of concertinaed.
Yeah, it's quite peculiar as a design. It was basically, it's made of little rows, and then is what makes the particularity of the antenna. Because usually an antenna is generating a round beam on Earth. Like if you have a torchlight and you illuminate something, you're going to see a round blob. What the antenna on OneWeb spacecraft does is it generates a beam that is like a sliver, and instead of being round, is elongated, and that's because you have to blanket the whole Earth with it. So basically, it's all about efficiency and having it as efficient as possible, as lighter as possible, as low power as possible. So the design is really about efficiency.
Now, the antenna on the OneWeb satellite is fixed, like many satellites. Where do you see the future?
In the future, the design of the antenna on the OneWeb satellite is very advanced anyway, but yeah, obviously for the future we are looking at the future technologies, so active antennas. The future is for beams to concentrate where the capacity is, to leverage the possibility to give to the customer what they want.
So lots of advances to be seen in the
working on it, yeah.
You're working on it indeed. And Sara Mugneni, thank you very much indeed. And you're going to be here for quite a while still?
Yeah, I think so.
Excellent.
Thank you.
Excellent. Thank you very much. And back to Paris from a marvellous watch party in London. Over to you, Katie.
Oh, thanks very much, Sue. It looks like everyone's had a great time there, and that was the last time we'll be going to Sue and the gang in London, because it's 11:30 over there, so they'll be winding their party down for now and picking up the rest of the information. So we are going to hopefully now get a mission update from the CEO of Arianespae, Stefan Israel, and we're waiting to hear from him. I just wonder if he's there now. Maybe we'll just hang on. We'll just hang on a little bit, because he hasn't come yet to the microphone. So we'll hang on for that. I tell you what, I wanted to ask you, David. We were talking earlier. We heard from the gang in London there, the students, about the Space Hack project and the debris, which was fascinating to hear about. And I know this is a subject that's close to your heart as well, isn't it?
Well, first of all, can I say on behalf of anyone who was once a 12-year-old boy that anything named Spider-Man is going to be cool. But debris is seriously a very big problem, and as we launch these mega constellations, it's something that we all have to take very seriously, and we all have to take responsibility for. The view of OneWeb, you know, we have a motto: leave no trace in space. And essentially what that means is that everything that goes up has to come down again. That has been true for millions of years on Earth until we started launching stuff into space. And we discovered that it just stays there and stays there and stays there for a long time. And in the early days, they would just leave things there, and those things are still orbiting today. So we've done a great deal, I think, in order to make sure that we are responsible citizens of space. You know, big things and little things, right? So one of the examples that all of our orbital planes are about 4 kilometers apart, right? And the idea is that the satellites miss each other. So even if one of the satellites loses control, we don't expect that to happen, right? But occasionally accidents happen in space. And if you lose control of 2 satellites in 2 different planes, they have a chance to collide with each other if they're at the same altitude. So by separating a little bit, it means that objects in different planes, even if they go into this defunct state, which we're not expecting, will continue to miss each other for a very, very long time. We also have done all of our mission planning around not just bringing the satellites up, but having enough fuel to bring them back down again. And to do it more quickly than the regulations require. So, you know, traditional regulations require a very long period of time that things are allowed to loiter into space, and we're trying to do things much, much more quickly, because we recognize that if we pollute this orbital altitude, we're hurting ourselves as well as everybody else.
Indeed, and it's our planet and we need to look after it. The atmosphere is very much part of our planet. It's our gas mask, and the space around our planet is important to us, so it's good to hear that. And of course, the launch vehicle, or the frigate upper stage, will be deorbited as well?
Yeah. So after the last satellite separation, so the 9th one, there will be a new ballistic phase, but after that there will be a third ignition of the frigate main engine to deorbit the frigate and the dispenser, and to perform a re-entry. And the drop zone is located in the Atlantic Ocean.
And that will occur very quickly after this mission ends. So before you wake up in the morning, the frigate will already be out of space, and it will just be our satellites cruising up there.
So something else I wanted to ask you about, David. We launched the first 6 satellites a year ago on a Soyuz launch vehicle. We launched it from the Guyana Space Center. David was lucky enough to come out to French Guiana and experience the mosquitoes.
And the sun.
And the sun. Vincent, of course, has been there many times. It's the European launch zone, which is where we launched 3 different rockets from, and Vincent was telling us all about those earlier. We're building the new site there as well, of course, for Ariane 6. But before we come on to that, we've touched a little bit on, this has been a very good year for you because you've got 6 satellites in space and you've learnt from those satellites. Building a constellation from scratch is quite an awesome thing to do, isn't it?
So what makes it, yes, absolutely. It's a phenomenal challenge, and it's really that challenge, I think, which for a lot of the engineers has drawn us to this project. It's just a fascinating problem because you have to build the satellites, of course, and we've done changed the way that you build satellites. But there's a lot more to it than the satellites, as you saw, right? And so one of the things that you have to do, so one of the questions you might ask is, I build all these satellites, how do I know what I'm actually going to get, right? In such a complicated system, in such a complex system, how do you figure out what it is that you're actually going to be able to deliver? So we actually have a very extensive systems modeling team. This is the team I run at OneWeb. We're not the only ones who do modeling by any means in OneWeb. We've got orbital people and people doing all sorts of things. But the core mission of my team is to make sure that we understand exactly what should be happening, when it should be happening, and that we understand if we want to say we have a bunch of airplanes flying around and they all have certain kinds of antennas and they have certain kinds of data plans and the satellites are flying a certain way, that we understand what they're going to get and that we can make promises to our customers about what they're going to get.
Great. Well, thanks very much for explaining that to us, David. And it's been a great year, hasn't it? And I'm really pleased for you and pleased for everybody at OneWeb. So we're going to head back to London now and back over again to Sue, because I said it was the last time we were going to see them, but actually they've got more to tell us. So let's go back to you, Sue, in London.
Welcome back to London, and I'm joined by Vikas Grover, who's the Chief Information Officer at OneWeb. Now, you gave quite a rousing speech to all the employees at the start of this watch party event. How important is this launch for the company?
Thank you very much. This launch is very special for us in the sense that this is the first time we are actually sending out 34 satellites in one go. So in our previous launch we had 6 satellites, and this is now 34 satellites. The important thing here is the satellites are getting produced in the manufacturing line in Florida, right? And this is the manufacturing line which is producing hundreds of satellites for us, which will become the new norm of the future. So this first satellite launch starts to create the rhythm for us for multiple sort of launches that are actually going to happen this year. So success now is a great step forward. The second important thing to keep in mind is the community, which is actually looking at this as technology opportunity, business opportunity, is actually keenly watching us. There are people who are interested in investing in our businesses. They want to see successes coming out at this point in time before they actually make their decisions. And so success here now is fairly key. And this, in my mind, is a giant step for mankind, because we are actually creating broadband on Earth, which is powered by space, which is not the norm at this point in time. So I feel that this is going to be this is going to create a good future for us. We have a number of engineering designs that are now coming alive. So putting 34 satellites on a single dispenser is a marvelous engineering concept and design. And now you actually see that coming alive. Releasing these satellites in different orbits and at different times, and ensuring that we are able to listen to these satellites once they're released, is another engineering marvel that you're actually now starting to see. So for us, this is a fabulous moment, and success here actually creates huge success going forward for us.
Now, what's I found quite interesting from the people I've been speaking to this evening and surrounded by is that particularly the GNOC team earlier on, that it's quite a young team, a young company,
yes,
in terms of its employees.
It's fascinating you say that. So even though the satellite technology is fairly old, and we've had 60, 70 years of satellites, what you start to see now is the emergence of a new age for satellite industry. And we now see assembly lines which are actually manufacturing satellites or 2 a day, 3 a day, versus satellites getting produced in the past, which were like one would get produced in 7 or 8 months, right? You now see, because of the pace of change, because of the change in computing capabilities, because of the change in the way the networks are now connected, more younger people are actually on the horizon, and this is about software, this is about engineering and deep engineering for space. So absolutely, I mean, people who are running operations are always young, but what you find in the satellite industry is actually the emergence of the young talent, which is actually going to take us to the future. Key things here is this is not about launching a satellite. This is about maintaining the sanctity of space. This is about ensuring space is clean. This is about ensuring all the designs work well. So fascinating time for us, and the guys from the Satellite Operations Center, the guys from the GNOC, the guys from Systems Engineering from OneWeb, actually doing a fantastic job, and I'm really proud of them.
Well, there's certainly, there's still a lot of excitement here tonight.
Yeah, absolutely. I mean, we're not only excited. I mean, we've done a significant amount of heavy lifting in the last 12 months, right? Some of which I actually spoke about earlier, but there are aspects around now getting user terminals set up, We have setups done in Palermo where we're now testing the user terminals and connecting them to the satellites and actually driving the capability of connecting high-speed broadband with the mobility ethos of connecting airplanes, boats, ships, and providing an experience that will truly be a marvelous experience for mankind. And that's the way I look at this. I mean, in my mind, this is a similar junction that we saw when we saw mobile phones starting to emerge early in the 90s. I see this as a very similar cycle taking shape in 2020, and hopefully this will be the launch of a technology and an experience that we will all be proud of.
Well, best of luck in the future. Vikas Grover, Chief Information Officer of OneWeb, thank you very much indeed. And now back over to Paris and Katie in the studio.
Thanks very much indeed, guys. Yeah, and as he was saying there, we're certainly on the verge of a lot of new and very, very exciting technologies. One of the new things that's happening for Arianespace is the Ariane 6 launch vehicle, which you were telling us about, Vincent. So just to fill everybody in, at the Guyana Space Center, which is in South America, on the northeastern tip of South America, it's the European launch zone. At the moment you guys are building a new launch pad, a brand new launch pad for the Ariane 6 vehicle. How's that coming along?
Yeah, so a new launch pad fully dedicated to this new launcher, so to Ariane 6. So everything is almost completed, so ready to initiate the first campaign. So we have a new launch pad with a complete new mobile gantry to welcome the Ariane 6 launcher. So the Ariane 6 maiden flight is foreseen this year with 30 OneWeb satellites. So we keep some performance from the launcher. That's why there is only 30 spacecraft on top. So there will be 30 spacecraft on top. So we keep some performance for the other objective of the mission of this maiden flight. So we have other objective. Validation and of different maneuvers, validation of reignition, validation of different things to prepare the next mission for this new launcher.
And you've seen that launch pad, haven't you? You've actually visited it. I've driven past it, but I haven't actually been on it.
So I got to visit it last year. It was not done. But one thing I can say that impressed me much is that it is enormous. I mean, the flame, what are they? The flame trench? They're not trenches for this one. They have a different structure there. But these enormous constrict structure. And you get the feeling that something very, very large is about to come in there. And so I think it's an exciting rocket for us. I think when you're launching a lot of satellites, it's always nice to be able to launch more of them. Even though we're not doing it on this one, obviously the capacity of this rocket is much larger. So I think it's going to be a fantastic launch for us to see, just to, as an engineer, just to see the impressiveness of the size and the scale of that.
I've been to the launch pad, the Soyuz pad in French Guiana, which I must admit was a really wonderful experience to see it. But what I found really remarkable was that there's a little tiny bush right by where the launcher goes off, and that bush is thriving. And we would imagine that it would get burnt by the fumes, but by the ignition. Yeah. But no, it certainly doesn't. So we're hoping now that we might be able to go over to Stefan Israel. We're still waiting to hear from him from our mission update, just to check in and see how things are progressing. And I'm just going to have
He's not yet in telemetry range. He's still coming around, and hopefully soon.
So Stefan is now ready, and I'm going to hand over to you, Stefan Israel, the CEO of Arianespace.
Ladies and gentlemen, distinguished guests, so I come to you to announce you and to confirm you that the 6 first satellites of the missions have been targeted as planned, and we have just had by our customer OneWeb the confirmation that they have sent signal. They are in good health. We are now waiting for the confirmation of the deployment of the solar panel, but up to now, everything is 100% nominal. You know that we have 7 more separations to occur up to the end of this mission. At the end of this mission, we will have separated 34 satellites. But now, I just wanted to tell you that everything is going as planned and that we have already outstanding news of the separation and the acquisition of the 6 first satellites of tonight's mission for OneWeb. Thank you very much.
Good news then. We have confirmation there of separation of the first 6.
It does, and it sounds like we got contact with them from our SOC as well.
So that's great, and good news from Arianespace's
so first
side.
step successfully performed, so it's great. So we are all looking forward to the next one. Yes.
This is the exciting part. The rocket is dramatic, but hearing from them, that's the exciting part for the engineers.
Absolutely. So we're going to take a break now because the satellites are going to, the school bus is going to keep delivering the next few batches of satellites, and that's going to take another, from now, about another sort of hour and 40 minutes roughly. And we're not going to follow that on air. We're going to come off the air and come back to you again in roughly an hour and 40 minutes. Keep your eyes on the screen and join us back then for the separation of the last 4 satellites. And hopefully we'll be able to declare the mission a success. But we will see you in about an hour and 40 minutes. Bye for now. 3 hours and 40 minutes into our mission, which is to deliver 34 satellites for the OneWeb constellation into space. I'm here with my studio guests, Vincent Baudel, who is from Arianespae, the company delivering the satellites, and David Nemeth, who's here from OneWeb. David, why don't you bring us up to speed what's been happening over the last hour and 40 minutes or so?
So while we've been drinking coffee and having a break here, the frigate has been hard at work. It has been scheduled to make another 5 stops, separations 3 through 8, on its mission. It is now coming up to do separation number 9. And we have confirmation that separations 3 through 7 have been confirmed through telemetry. We have not yet gotten confirmation on 8, but that has been scheduled to happen, and so far so good.
Great, and here we've had the scheduled switch on of the frigate upper stage. That's the gold structure you can see there with the dispenser attached. We call it a dispenser. You can also call it an attachment mechanism. And actually, I think frigate is a really fascinating piece of kit, isn't it, Vincent? Because it's the upper stage of the launch vehicle, but it's very clever. It can do lots of stuff. It can turn its engine on and off. The Russians have designed a lot of interplanetary vehicles over the years, and they've used that technology to design the frigate upper stage. And that makes it very versatile, doesn't it?
Yeah. So the frigate upper stage is a restartable upper stage, so up to 7 times, and offering great flexibility to servicing a wide range of orbits and allowing delivering the payload to different orbits in case of shared launch. So its flight profile is adapted to the orbits required by our customer, but also adapt to the configuration of the upper part. So, for example, for GTO mission, the typical profile for frigate is a direct injection profile with a single frigate burn.
I'm going to just interrupt you there. So when you say GTO, you mean geotransfer orbit, which is an orbit that takes you to geostationary orbit, which is 36,000 kilometers above the Earth.
Yes. For circular orbit or highly inclined orbit, the typical profile is an intermediate orbit ascent with 2 burns. And in case of multiple launch, several frigate burns can be performed to transfer the payload in a wide variety of final orbits, providing the required plane changes and orbit raising.
So I wonder if we can see the CGI images that we have, the 3D simulation images, so we can actually see the frigate upper stage, because it would be interesting to explain to everybody what it's made of. Is that gold structure there? What's on board? Yeah, so you can see the MLI envelope all around the frigate upper stage. So inside there is, in fact, it consists in 6 spheres. You have 2 spheres for the avionics and 4 for the storable propellant. So you have 2 tanks with UDMH, so it's unsymmetrical dimethyl hydrazine. Goodness, that's a long name.
And 2 tanks with NTO, that is to say nitrogen tetroxide.
And these are the fuels or the propellants which are effectively propelling us. David, we are up very late, as you mentioned. The coffee cups are building up upstairs in the green room.
And the cigarette butts.
For some people. And why are we up so late tonight?
So that's an interesting question. The last launch, as you remember, was a very reasonable hour. Plenty of time to go to a party afterwards, and it is now, 2 in the morning here in Paris time?
And I'm just going to interrupt for a second, because this is obviously the scheduled moment now to separate our last batch of 4 satellites. That's what it looks like. They move away from each other, diametrically opposed. I guess that's designed to stop them from bumping into each other, amongst other things.
That's right, and to make sure that they all go with the right velocities. But back to your question about why we're up so late tonight. So the interesting thing is that we have what we want ultimately is a constellation with 12 different planes. So satellites going in 12 different orbits evenly spaced around the Earth. So when you launched the first satellites, you could do it at any time, and it was fine. But we already have 6 satellites up there, and they are now in plane number 2. And we are launching in plane number 12. So what happens is you want to launch the satellites into the plane, so as the Earth turns, you have to, if this is plane number 2 over here, and this is Baikonur, right? As Baikonur comes around, we want to launch when Baikonur is under plane number 12. Well, that's only going to happen at a certain time of day, actually AM and PM. So if you want to do that, you have to make sure that you have launched at the right time when you've come around so that you can have the correct orbit. Now, you can shift planes. It's a procedure that takes some time, and we'll occasionally do that for some of these launches. But generally, you don't want to do that for very long or very far. So as these launches go on, the times will be kind of all over the map, depending on which plane we're launching and in which month we're doing the launch.
Well, and that's going to be fun to see. So let's take another break now, because we are, 3 hours and 47 minutes in, and we're going to be waiting now for the confirmation, because as Vincent has explained to us earlier, we are going in and out of the range of the tracking station, so we're going to wait now to go into the range of the next tracking station before we can find out what the latest is on our mission. So we're going to come back to you in just over an hour to find out how it all went, and we'll see you back here in just over an hour. Bye for now.